Okay. We are going to work with the gases and study the gas law today. With the gas law, there are more than the two that we are studying today. Basically, the gas laws, they show the relationship between pressure, temperature, volume, and number of moles. So when it's showing the relationship with these, and each one was kind of introduced by different scientists, and most of them, they come up with they are known by the name of the scientist who actually presented the first time. So we have Boyle's law, we have Charles' law, and then we have Gay-Lussac's law. So we have three that there's coming by the names, and we have combined gas law. We have gas laws for ideal gas law. The ones that we are going to present today is actually work on it is the Boyle's law and the Gay-Lussac law. One thing you want to know for sure when we are using the gas laws, the temperature must be in Kelvin if we are dealing with the temperature. It doesn't. Other units do not work for gas law. So the Boyle's law, it shows the relationship between pressure and volume, and the relationship between pressure and volume is that they are inversely proportional. What does it mean? It means if the volume is increased, if the volume is doubled, pressure is going to be cut in half, and vice versa. So if you lower the volume, pressure is going to go higher. So the pressure and volume, they are inversely proportional. The Gay-Lussac law, it shows the relationship between temperature and pressure. When the temperature goes up, pressure goes up. What is causing the pressure? What's definition for pressure? Definition for pressure is force over area. So the smaller the area is, the higher the pressure. So if you look at the definition for pressure, that means you have the pressure equals force over area. So if you increase the force and you don't change the area, pressure is going to go up. So force goes up, pressure would go up. If the area or the volume is decreased, pressure is going to also increase. So because you're not changing the force, but you are changing the volume. If you change the volume, the lower the volume, pressure is going to be higher, increased, because the force did not change. Now you can change the pressure by either changing the volume, you can change it by pressure, and you can change it by number of moles of the gases. So if we say the relationship between temperature and pressure, which is the Gay-Lussac law, how those two are related? Can you tell me how those two are related? Pressure and volume. You can use the chat to answer that question. Volume is going to be constant, yes. We always have two constants. So volume and number of moles is going to be constant. So if I start with a specific amount of the gas, I'm going to keep that number of the moles of the gas the same. Pressure goes up, temperature goes up. So pressure depends on temperature. So if temperature goes up, pressure is going to go up, and that is because, I don't know, you see this formula I had on the board or not, the pressure force over area. If the temperature goes up, basically when you increase the temperature, you are increasing kinetic energy of the molecules of the if you increase the temperature, you're increasing the kinetic energy between the molecules of the gas. And if they are moving now faster, they have higher kinetic energy. When they hit the wall of the container of the gas, they cause more force. They are hitting more forceful, and when they hit more forceful, they cause more pressure because because the force is going up. As a result, pressure is going to be higher. So if you increase the temperature, pressure is going to be higher. So the relationship between pressure and temperature is going to be direct. So they are directly proportional. If one goes up, the other one also would go up. So when we have linear relationship, what does it mean? It means if one goes up, the other one goes up. This is like Gay-Lussac law. If the temperature goes up, pressure is going to also go up. A non-linear is like when you plot a graph, is not going to come out linear. The shape of the graph is not going to be linear. So you have like a non-linear for inverse or non-linear direct, because it's increasing. That means is direct, but is not linear. This linear relationship is inverse relationship. This would be for volume and the pressure. If one increases, the other one is going to decrease. So we have linear but inverse. So this shape of the molecule that you have here is going to show the relationship between pressure and the volume. So you have if you plot like when it's inversely proportional, if instead of using volume, you would use 1 over volume. So you find the reciprocal value for the volume, and then you plot the graph. We can find the linear relationship or direct relationship. So in Boyle's law, we are using the same interface that you see in the picture here. So we are going to use the same syringe that we have here for the Boyle's law. We are going to start with 10 milliliter of the gas, and when I adjust this syringe at 10, exactly 10, I'm not going to change. I'm going to attach to the interface once. I'm not going to open this again, because if I open it, some of the gas can go out, or more gas could go in, more of the air would go in. So we are working with the specific volume of the air. That means number of particles of the air is constant. So the temperature is going to be also constant. We are not increasing the temperature, we are not decreasing the temperature. So when we are dealing with the Boyle's law, temperature is going to stay constant. Temperature is going to stay constant. Number of particles is going to stay constant. But what we are going to do, we are going to increase or decrease the volume by pushing the syringe in or pulling it out, but to increase the volume. And when the volume is increased, using the computer, we have an interface here that is going to actually read the pressure, and with the pressure that there's a computer program which we are using the interface for, and the pressure is going to be recorded as numerical value in the computer, and we're going to record those numbers. When you have those numbers, basically at different volume, what is the pressure, you have like 5 or 6 data based on the table that is provided in the procedure. Then you have the numbers, and you follow the instructions on how to plot the graph and come up with a linear graph, or examine under what condition you get a fixed number value for k if you divide the x by y or multiply x by y, basically is showing the relationship is going to be inversely proportional or directly proportional. For effect of the temperature, we are going to start with a specific amount of gas in a flask. We close this gas valve after I have the volume set up, or I take the gas at room temperature. The volume of the gas does not change. The only thing, because it's a closed container now, I'm not going to open. I'm not going to, and the glass is not going to be changing volume, because if the volume of the glass changes, then glass would shatter. We cannot decrease the volume or increase the volume of the glass, because the glass is going to shatter. So the volume is going to stay the same. Number of particles, which is number of moles of air inside the flask, is going to stay the same. So only two variables is going to change at the time, unless you are dealing with combined gas law or you are dealing with ideal gas law, which I'm sure you are going to learn about those in lecture. But in the lab, we are using only these two setups for Boyle's law and Gay-Lussac law. So for Gay-Lussac law, we keep the volume constant, we keep the number of particles constant, we increase the temperature, and by increasing temperature, we read the pressure to find out how the pressure is going to change. So your pre-lab questions, it's already, sure they are already done. And then you found the relationship based on the graph that you had. And after the pre-lab, now we are going to follow the procedure in order to perform the Boyle's law. As we perform the procedure, you are going to record your numbers in the table you have provided in the data sheet, or the experiment, the data sheet. You are going to record these numbers: volume and pressure. The next column, the next three columns, those are calculation which you do after we are done with the experiment, and you process your data based on the values that you find for volume and pressure. You change the volume, you measure the pressure. So interface is going to measure the pressure. So basically pressure depends on the volume. So when you are using the pressure should be on the y-axis, because it's dependent data. When you are plotting graph, your dependent data should be on the y-axis and independent data should be on the x-axis. What does it mean? The one that you have control over, that's you are going to change it and look for the result for the other one. That is independent. Like in this case, we are changing the volume of the syringe, or the air that is inside the syringe. We are changing the volume. We have control of what should be the volume. And then when we are done with this, when we change it, we measure the pressure. So changing the volume, I have control, and that's what we are doing. And then we are changing. That's the variable that we have control. And then change in pressure is the result of the change in volume. The second part, and then you answer these questions. The second part for Gay-Lussac law, we are going to measure the pressure at cold water or ice, room temperature, hot water, and boiling water. We have 4 different temperatures. We measure the pressure. You have to record the temperature and pressure. You do these calculations later and answer the questions you have. And please try PDF. Please do not use picture. You do not use your phone and use a picture, because PDF scanning is like, it's a free app you can download for both Android and the iPhone. So it's called Cam Scanner. It's much easier for me to read when I'm grading. And then when you scan, it gives you a choice to send it as a PDF file. And when you scan using Cam Scanner from your smartphone, actually it combines all the pages. So you don't have to submit 4 or 5 separate pages. It's under one document. You just click on document and then you submit it. It's going to be much easier for you because it's one submission, and it's easier for me because when I'm opening the PDF file, it opens as a full page. But if it's pictures, especially, there's one format of the pictures that is like when you take the picture by phone, some phones they record it as HCI something, and I don't have even the program to open it. Then I have to say, please change it to JPEG, because if it's not JPEG, I can't open it. So anyway, okay, we're going to start the, let me start with the experiment. I'm going to pull up the table here, and you tell me what to measure. Okay. Do you have any questions? You can chat with me if you have any questions. You could write your questions down if you have any. And I'm going to open the procedure. I want you to see the experiment. And hopefully you could see it clearly with the computer screen. And we change the volume. It's very fast. It's like very fast experiment. So it's usually takes 15 minutes to finish the experiment if the hot water is available. The data sheet, let me look at the extension part to see what is required for the extension. The data must be given to you. If not, no, we are not. Yeah, even here, if you were in the lab, we could not, because these are not connector printer, we couldn't plot them by the computer if that's what is asking. But so you just record those numbers and then you answer the questions based on the data that you collect. And I will let you know what is the, let me see what is the pro part, last part. Extension using the Logger Pro. No, you can just, what you do, you just plot the graph, but you have to plot the graph. You can plot the graph using Excel and upload, or you could plot the graph using paper and pencil and take your picture and upload, or scan and upload, rather. So there is no need for the Logger Pro, using the Logger Pro in this case. Because even if we can do that, we cannot print it here. Okay, let me stop sharing the other document. Now we start the experiment. Can you tell me what are the steps for the experiment? What should I do? Because I have not opened the... I printed the first one and then I decided not to print others. So okay, what's the first step? Can you give me the steps, please? First step, connect the syringe, disconnect it from the gas pressure sensor, pull it to 10. Okay, exactly at, so I'm going to have it, you check with me. So we're going to set it exactly at 10 and then connect it. Perfect. Next, so I have 10 milliliter of the air that I'm going to work with. Attach it. Okay, I did attach. Do I do the pressure now? Can you read the pressure? Is red color here. Can you read the pressure? So, yes, perfect. So this is 10 milliliters. And then if I say collect, it's going to record the pressure. Okay. So record this pressure in your paper, please, because I don't want to make sure that is on the chat so we can go back if someone has question. Is 102.59. 102.59. What is the next volume? Let's see if I can. This was the 10 milliliter. Okay. Next volume. The next volume is, what should be the volume? Next volume. 20? Are you sure it goes from 10 to 20? So it is 20. I should pull this to 20. Is it 7.5 or 20? Next volume. 7.5? So if you read the procedure and tell me. Okay, 7.5, 10, thank you. 7.5, so I'm going to push this to 7.5. What do you think will happen to the pressure? Okay, the pressure has increased at 7.5. The number is 136.13. That is a kilopascal. Can you record that number, please? 136.13. That's for 7.5 milliliters. Okay. And the next volume was 10 again. 10, thank you. So I go back to 10. At 10, 1, just record what it says now here because, no. At 10, 102.45. For 10 would be 102.45. Slight change, but it's okay, just record it again. And after 10 would be, next volume, 12.5, perfect. So I'm going to pull the syringe to 12.5 mark. And that number is 83.27. Perfect. Next volume would be 15, right? 15. That number is 69.48. So if I pull it to 15, is a 69.48. Okay. Next volume is a 17.5. Looks like it, right? 17.5, the number is 59.6. Okay, it's pulling, so 59.43. 59.43, perfect. And then 20, right? Last one is 20. What do you expect? Should it go down or high? Pressure should go down, and it is 52.30. 52.30. Perfect. So you have all your numbers, and if you write them in the table, and look, examine your data, make sure that nothing went wrong during the experiment. So basically what's happening, as you increase the volume, the pressure should decrease. So you can check your numbers, make sure that the pressure is decreasing as you increase the volume. Does it sound okay? Your numbers okay? It's decreasing. Okay, perfect. So we can move to the next. We can move to the next one. The next part of the experiment, which is the effect of temperature. For effect of temperature, I'm going to move to bring the card because I have to move the computer. How many wires? Okay. Go to the setup for the other one. Gale set. I have to have 4 temperature of water. So I need hot water, I need boiling water, cold water, and room temperature. Can you see the setup? Yes, could you see the setup here? Just want to make sure that you see the setup. And we need to first going to show you the container that of the air we have. When I open this valve, this is going to get enough air to fill up the this is going to fill up um, the flask with filled up with the air. So it's going to fill up at room temperature. That's the only time I'm opening this valve. If I increase the temperature, decrease the temperature, I'm not allowed to open this valve again, because if I change it, the air can go in or it can come out. If the pressure is higher inside, it will go out, and if the pressure is lower, the air would go in. So I'm not allowed to open this anymore. I'm going to start with the cold water. So I have to place my flask inside the water, hold it inside the cold water, measure the temperature of the water, and measure the pressure at that given temperature. So to measure the temperature, I'm using a thermometer to measure the temperature, and I'm placing the flask inside I have to get it as far possible as in. We're going to leave it in cold water. Temperature is going to be recorded. I'm going to zoom on the temperature on the computer screen now. Do you see the temperature and the pressure? What's the temperature? What's the pressure? I just want to see if you can see it or not. Pressure is 94.57 and the temperature is 6.2 degrees Celsius. Did you record it? You cannot see? Okay, so I'm going to read the number. Please record it. 6.5 degrees Celsius. And pressure is 94.31. 94.31. And that is kilopascal. This is for ice water, yes. I don't see the pressure. 94, okay, 0.31. I'm going to take it out and place it in room temperature water. And to answer some of your questions that you had on the chat, the first volume you gave me, it was 7.5. You did not tell me to measure it at 5. So I have to go back and measure the pressure at 5 milliliters, because the first volume that it was given to me, it was 7.5. The one that I measured, it was not 5, it was 10. I just measured as a practice before starting the experiment. So I go back and repeat that. Yes, it was 10, the first one ever. Before 7.5, it was 10, 9. I have to go back and do the 5 again. Okay, temperature change, pressure change. If you can see, perfect. If not, record the number 21.9 degrees Celsius. That is the temperature. And pressure is 101.69. 21.9, 101.69. Perfect. Okay. Next, we need hot water. So we're going to try the pressure in hot water. Okay. I'm using my hot gloves to get some of the boiling water to add to this room temperature water to get hot water. So what should be the temperature of the hot water? Like anywhere around, if it's higher than 40 degrees, it should be fine. That could be considered hot water. I don't want to make it too hot because that would be boiling. So a temperature will allow to heat up a little bit more. I want to make sure that it goes higher than higher than 40. Heat it up to 45. And place the flask inside. Okay, the temperature is 40. Temperature is 46. 46.5. Record the number, please. Temperature 46.5. And pressure 116.35. 116.35. Okay. That was for hot water. I am going to wait until the temperature increases to over 75 because it's boiling water, but working with boiling water might be slightly inconvenient to hold it in, but definitely 75 or higher. So while the water is boiling, I am going to use the time efficiently. I'm going back to the other setup so I can try the 5 milliliters for you. Find out 5 milliliters. What would be the okay? For 5 milliliters, let me make sure that I stay still. For 5 milliliters, 199 point. It moved though. 199. Let me. Okay. I'm holding still. Can you see that number? You can record that number now. Is it 201 point? You know why it's changing? Because it's too much pressure here and it keeps pushing it back to me. And by the time when I concentrate on the number, this comes out. You see, it's just automatically it pushes back. So I'm going to hold it still. And if you could see that number, just record the number you see now, whatever number it is. 197.14. Okay. 197.14. Perfect. So that is the number for 5 milliliters for Boyle's law. Now you could answer all the questions. Right, we're still waiting for the boiling water or the temperature that I said I'm going to make sure that it reaches at least higher than 75. When it reaches higher than 75, it will show the increase in the pressure. So your graph should look okay with the number. Of course, the higher the temperature, the higher the pressure is going to be. Too bad you can't see this screen. Any questions for me? Yes, the 5 milliliter that I measured, that was for the Boyle's law. So you have to go to the first page of your data sheet and it goes into the box that you have, the table you have for volume and pressure. The 5 milliliter was missing. Okay. Temperature is 80. Is that all right now? Just keep in mind the temperature used, the unit for temperature used in gas laws must be in Kelvin. The temperature we are recording is in degrees Celsius. So you do add the 273 in order to change Celsius to Kelvin, degrees Celsius to Kelvin. Okay, I'm going to turn off the heat and leave the beaker on the side so the temperature stays constant. It doesn't keep like moving up, because if it does, the temperature as it goes up, pressure would go up and we won't have a fixed number for you to record. Not sure if you can see the screen, but I will read the number to you. First, we have to place this in hot water. Going to place in hot water. Going to wait for the pressure to stabilize. So I place the flask in hot water. For the temperature, temperature 80 for the temperature. The temperature was 82.0 and the pressure was 147. Temperature 82 and the pressure was 147. I don't remember the decimals. And the pressure was so high that it actually popped out. So if I do it again, it's not valid because air went in, but I do remember perfectly that it was 147. The decimal, gonna put like a 50 because we don't know what was the number. So 147.50 for the pressure. Okay. Oh, the pressure was actually very high. Okay. Do you have any questions? Did we include everything from the data sheet, the data that you need for the experiment to complete your data sheet? Yes? Okay, perfect. So I can answer your questions at this point. If you have any questions about this experiment. No questions about the experiment? Okay, I'm going to stop the recording and I answer your concerns and any questions that you might have regarding the gradebook, regarding any other concerns that you might have. Okay, I'm going to stop the recording and I'm going to